Good afternoon, students. So, in Unit 5, Motion of a System of Particles and the Rigid Bodies, today we are going to see the fourth topic that is, we are discussed in the last class, the center of the masses distributed to the different points. Now, we are going to discuss about a center of masses of the 2-point masses. With the equations for the center of mass, let us find the center of the mass of the 2-point masses m1 and m2 we are taking because we are taking for the two masses. That's why we are taken as m1 and m2. But we are taken only one Cartesian coordinates, that is x we are taken x-axis, and in that x-axis two masses are there, no? So we are taking the two positions, that is x1 and x2 respectively. So in this case, for this case, we can express the position of the center of the mass in the following three ways based on the choice of the coordinate system. So what is the first position? Means when the masses are in the positive x-axis. We know that it will be in the x-axis or in the origin or in the negative axis. So first case we are taken that the masses are on the positive x-axis. The origin is taken arbitrarily so that the masses m1 and m2 are at the positions x1 and x2 on the positive x-axis. So the center of the mass will also be on positive. So that's why we are taken as xcm. You know that what is xcm, I already discussed in the class. That is xcm is nothing but the center of mass of x-axis. So that should be given in the equation. We know this equation already because in the distribution of masses we are taken that the summation of mi xi by summation of mi. Same thing we are taken here also, but for the two masses case we are taking like this: m1 x1 plus m2 x2 by m1 plus m2. So this diagram is also given here. So how the masses are on the positive x-axis. See the one mass, the red point denotes the center of the masses. That is, you know that what is the midpoint of the two things. So same here, but here we are taken as the two different masses. For the two different masses, the center point we are taken as a center of mass, that is denoted in the red point. And m1 is the left hand side one, and then m2 is on the right hand side one. And x1, what is the value, and x2 means x1 we are taken from the origin, that is from o to m1, that is taken as an x1, and x2 is taken from o to m2. So but the center of the mass is between the o to cm, that is center of the mass, that is given on the diagram. So the two masses are in the axis of x-axis and also in the positive x-axis. That is the first case given here. And what is the second case? So in the first case, two masses are on the positive x-axis itself. But in the second case, we are taking one mass on the origin and the other one is on the positive side. So when the origin coincides with any one of the masses, that means the calculation could be minimized if the origin of the coordinate system is made to coincide with any one of the masses. When the origin coincides with the point mass m1, its position is x1, so that is equal to 0. So we know that if any point is on the origin, we considering that has to be a 0 1. So for this also we are writing the same like xcm is equal to m1 of x1, so that is x1 is 0 plus m2 x2 by m1 plus m2. So the equation further simplified as xcm is equal to, so anything is multiplied with 0, that becomes 0. So we are neglecting the term of m1 and we are getting that m2 x2 by m1 plus m2. Okay, so see the diagram, it is clearly given in the diagram. See the diagram, the origin, that is O, it is am considering as a mass of m1. It is in the O itself, at the origin itself, and the center of mass is denoted in the red point, and m2 is on the positive x-axis. Here also we are taking the measurement in the same wise. From O to m2 we are taken as an x2, and from O to cm, that is taken as the center of mass of this two masses. Okay, so in this case we are taken one mass is at the origin side and the other one as in the positive side. In the before case we are taken both the m as in the positive side. when the origin coincides with the center of mass itself. In the two cases we are discussed, one will be on the positive axis and the other will be on, we are taken that is one mass is on the origin, other will be on the positive axis. The third case is when the origin coincides with the center of the mass itself. If the origin of the coordinate system is made to coincide with the center of the mass, that we are going to discuss as in the third case. So if it is coincide with the center of the mass, then xcm is equal to 0. That means the mass m1 is found to be a negative axis, and that will be shown as in the figure. So hence the position x1 is taken as a negative value. So we are substituting that minus x1. So for xcm it's taken as in 0. 0 is equal to m1 into minus x1 plus x2 m2. So that is equal to m1 x1 equal to m2 x2, and that the equation is known as principle of moments. So in this equation both the sides will be equal, that is m1 x1 equal to m2 x2, and this will be known as principle of moments, and that will be shown in the diagram. That is, see here, the center of mass, that is cm, will be taken in as an origin. So if it is in the origin means one will be on the positive side and the other will be on the negative side. So see here in this diagram it is clearly given as one mass we are taken in the negative side direction, and the other mass will be taken in the side of the positive axis. That's why we are taken that center of mass as a 0. Now you understood clearly. So both will be equal. So x1 m1 should be equal to x2 m2, and this phenomena is known as a principle of moment. So related with this topic, we are having one problem, that is in the example of 5.1. 2-point masses 3 kg and 5 kg are at 4 meter and 8 meter from the origin on the x-axis. So locate the position of the center of the mass for the 2-point masses from the origin and also from the 3 kg mass. So what is the solution has to be taken as, let us take m1 is equal to 3 kg and m2 is equal to 5 kg to find the center of the mass from the origin. The point masses are at the position x1 is equal to 4 meter and x2 is equal to 8 meter from the origin along the x-axis. So it is clearly given in the diagram, that is, see the diagram. So from the origin O to 3 kg and center at the cm and also the 5 kg, both will be on the x positive axis. So from O to 3 kg it is 4 meter, and from O to 5 kg it is 8 meter, and between the center it takes us xcm. So center of the mass xcm can be obtained using the equation. So we already obtained the equation in the before classes. So xcm is equal to m1 x1 plus m2 x2 and by m1 plus m2. So we are substituting the values. We know m1 is equal to 3, m2 is equal to 5, x1 is equal to 4 and x2 is equal to 8. So 3 into 4 plus 5 into 8, that's divided by 3 plus 5. So that is equal to 12 plus 40 by 8. That is 52 by 8. That's equal to 6.5 meter. So the center of mass is located 6.5 meter from the origin on the x-axis. This is the first case. That means from O to CM, the value, that is the distance, is 6.5 meter. That is we are calculated now. Okay, that is the center of mass of these two masses, 3 kg and 5 kg for the first case. So see here the second case, the origin is shifted to 3 kg masses along the x-axis. So what is the origin? Now the mass 3, that is 3 kg mass is at the origin. So now we are taken that 5 kg should be shifted as a 4m distance. So now we are going to calculate the xcm. So in this case what happens actually, the one value we are taken, that is x1 we will taken as a 0 value. So 3 into 0 plus the remaining values as such same. So anything into 0, so first value is obviously 0, plus what is 5 into 4, that is 20 by 8. So 20 by 8 is nothing but 2.5 meter. So from 3 kg point mass and 1 point from the 5 kg point mass. How they are telling this 1 point means from 3 kg it is taken as that up to the cm, it will be taken as 2.5, no? And what is the remaining of 4m? 4m minus 2.5 is equal to 1.5 meter. That is, they are telling that from cm to 5 kg the value is 1.5. okay, so calculated values answer is 2.5. so from that calculated we are calculating the another value, that is 1.5 meter. okay, it's a very simplest problem. All the values will be given and it's a straight substitution. So from that straight substitution we are calculated all these values. So this result shows the center of the mass is located closer to the larger mass. If the origin is shifted to the center of the mass, then the principle of moments holds the good. That is m1 equal to, that is in the third case, m1 x1 equal to m2 x2. That means 3 into, we are calculated now what is x1 and also what is x2. right? So m into 2.5 equal to 5 into 1.5, that is 7.5 equal to 7.5. so that is the center of mass. Comparing the case 1 with the case 2, xcm 2.5 m from the 3 kg mass could also be obtained from subtracting the 4m. The position of kg mass, 3 kg mass is 6.5 m meter, where the center of mass was located in this case. And come to the next problem, that is for a uniform disk of the radius r is given and a small disk of radius r by 2 is cut and removed as shown in the diagram. Find the center of the mass remaining position. Now we are taking the mass of an uncut full disk M, and center of the mass could be at the geometric center of the disk on which the origin coincides. Let the mass of the small disk cut and removed be M, and its center of mass is taken at the position of r by 2 to the right origin as shown in the diagram. See the diagram, that will be given in the diagram very clearly. okay, so what is r and r by 2 and where they are taking that r by 2 and which is the full m, everything is be clearly given on the diagram. So the remaining position of the disk should have its center of mass to the left hand of the origin, say at the distance of x. We can write the principle of moments, that is m minus m into x is equal to m into r by 2. So x is equal to, we are taking this m minus m on the another side, so m by m minus m into r by 2. So sigma is a surface density, so the mass per unit surface area, sigma is equal to m by pi r square. So then the small disk of m we are taken, so m is equal to surface mass density into surface area, so m is equal to sigma into pi r by 2 square. So m by pi r square into pi r by 2 whole square, m by pi r square by 4. So it's a simple explanation, that is they are expanding the equation, that means taking the that square. So r that is whole square we are taken out, that will be becomes r square by 4. okay, and cancellation, that is denominator we are having one r square and numerator r square, pi also getting cancelled, pi r square, so it becomes m by 4. So substituting small m in the expression for the x. So now we are substituting the values, and what happened to that equation means m by 4 by m minus m by 4 into r by 2, that's getting m by 4 by 3m by m by 4 into r by 2. okay, so what happened to this m by 4 and m by 4, 4 get cancelled, m by 3m into r by 2, and that will be 2 3 into 2 is 6. okay, m get cancelled and that will be equal to, x is equal to r by 6. So the center of mass of the remaining position is at the distance of r by 6 to the left from the center of the disk. So the third problem, position vectors of 2 point masses has to be given. One is 10 kg, another one is a 5 kg. Minus 3 I cap plus 2 j cap plus 4 cap into m, and 3 I cap plus 6 j cap plus 5 k K cap M respectively. Locate the position of the center of masses. So M1 10 kg, M2 5 kg. So we were able to write the R1 and also the R2, and R1 is given and R2 vector form is given, and what is the equation is R vector is equal to M1 R vector plus M2 R vector by M1 plus M2. So we are going to substitute all the values given already. So we know how to multiply this one. 10 into minus 3, that is 30. 10 into 2 is plus 20. 10 into 4 is 40 plus 5 into 3 15, and then 5 into 6 30, 5 into 5 25. So all these values we are going to make writing in the numerator side, and in the denominator side it is 5 plus 10, that is 15. And what is the I here? Minus 30i, and this side it is plus 15i. So minus 30 plus 15, it's equal to minus 15i, plus 20 30 equal to 50j, 40 plus 25 it's 65k by 15. So if we are able to cancellation this individually, so for only for the I it's 15 by 15, that's equal to 1. So it's considering as a 1, so that is minus I, and 50 by 15 is nothing but in 10 tables we are able to cancel that, or so it's become not 10 table, it's taken in the tables of 5, so it's 10 by 3, and again the same thing 5 table 13 by 3 for k. So the last equation is R vector is equal to minus I plus 10 by 3 j plus 13 by 3 k into m. So the center of mass is located at the position of R vector. So it is clearly given here for this equation. So this is the final equation, that is center of the mass is located at the position of R vector. We are going to see the next problem, that is the example of 5.4. In 5.4 what is given means the locate the center of the mass of the uniform rod. Mass is given as capital M and length is given as small l. Solution is you consider a uniform rod of mass M and the length L whose ends will be coincide with the origin. So the rod is kept along the x-axis. We are going to find the center of masses. So infinitesimal quantity is extremely small quantity, so we are going to see the diagram. It is given here. Dx is a small quantity and x, it start from O to dx, the value is x and the length is L. So of this rod we choose this small mass as dm and the length is dx at the distance of x from the origin. So lambda is the linear mass density. So mass per unit length of the rod, lambda is equal to m by L. And then mass of the small element dm is given as dm is equal to m by L dx. Now we can write the center of mass of the equation for this mass distribution is xm is equal to integral of x dm by dm. That is, we are taking the limits as from 0 to L, x into ml by ml into dx by m. That is, we are taking that 1 by L is a constant, no variations. So we are taking the integration only for the x dx part. Mm get cancelled, so it will be out, the mm get cancelled, so no value for the m, and 1 by L is a constant, so we are taking that also out, and x dx will have the limitations of 0 to L. So 0 to L integral of x dx. So we know that how to integrate. So after integration we are getting the value as x square by 2, and for that we are substituting the limitation 0 to 1 by L into L square by 2. So xm is equal to L by 2. So as a position, L by 2 is the geometric center of the rod. It is concluded that the center of the mass of the uniform rod is located at its geometric center itself.